This is Vrishali and you are watching Vrishraj Classes YouTube channel. In this video, we are going to continue exercise 1.3 of Arithmetic Progression, Mathematics of Standard 10. Most of the sums are already done. You can check the link of the playlist in the description box. Now in this video, we are going to solve problem number 18, 19 and 20 of exercise 1.3. So let's start with problem number 18. Before I start the explanation of this next problem, I would like to request all of you that please do subscribe our channel and do share these videos among your friends. So now let's start with this problem. A spiral is made up of successive semicircles with centers alternately at A and B, starting with center at A of radii 0.5 cm, 1.0 cm, 1.5 cm, 2.0 cm and so on as shown in the figure. What is the total length of such spiral made up of 13 consecutive semicircles? Here pi we have to take it as 22/7. Now here in this figure we can see that two centers A and B. Means first semicircle is drawn with the center A, then the next semicircle is continued with center B. So like this, for each next semicircle, the center is changed. A, B, this way. So like this, they are drawing 13 semicircles. And we have to find the total length of these 13 semicircles. So let's start solving. And here radii taken are 0.5, 1.0, 1.5 and so on. So let's start with this problem number 18. Here, length of semicircle. Length of semicircle is half of the circumference. Half of the circumference. Length of semicircle is half of the circumference. Means it is 2 pi r upon 2. 2 gets cancelled. And this is nothing but pi into r. Now length of semicircle is pi into r. And here what are our radii? 0.5, 1.0, 1.5 and so on. So here total length of 13 semicircles is going to be pi r1 plus pi r2 plus pi r3 and so on up to pi r30. Now here r1 is equal to 0.5 centimeter, r2 is equal to 1.0 centimeter, r3 is equal to 1.5 centimeter and so on. So here how to find this total length of this 13 semicircles? See, pi r1 plus pi r2 plus pi r3 up to pi r30. So this total length, okay, here this part, pi we will take common, r1 plus r2 plus r3 and so on up to 13. Fine. Now here r1, let us consider this r1 as a, which is 0.5. Then the common difference. Say this r1, r2, r3, it's our AP. It's forming AP. So we have to find here sum of these 13 terms. And this is the reason why we are taking this A, D and N now. So here A is 0.5, D 1.0 minus 0.5, that is 0.5 and number of terms is 30. So here let's find what is the sum of this 13 terms. Sn is n upon 2 into the bracket 2a plus n minus 1 into d. Here we have 13 terms. 13 upon 2 into the bracket 2 into 0.5, our a is 0.5 plus 13 minus 1 into 0.5. Total number of terms 13 and D is 0.5. 13 upon 2. 2 into 0.5. 1.0 plus 13 minus 1, 12. 12 into 0.5 is 6.0. So here it is 13 upon 2 into 7. 1.0 plus 6 is 7. Now this sum of this 13 terms is 13 upon 2 into 7. This is not our final answer. Here what we have to find? Total length of these 13 semicircles. So total length of these 13 semicircles, which is pi r1 plus r2 plus r3 up to r13. Now this is equal to, now pi we have to consider as 22 upon 7 into, we have calculated here r1 plus r2 plus r3 up to 13 terms, and this is nothing but 13 upon 2 into 7. 7 and 7 gets cancelled. 2 ones are 2 11s are 11 into 30. 11 into 13. 11 3s are 33. 11 ones are 11 plus 3. 143. 143 centimeters. So here the total length of this 13 spirals is 143 centimeters. Total length of 13 spirals is 143 centimeters. So here we complete our problem number 18. Let's move to problem number 19. Problem number 19. 200 logs are stacked in the following manner. 20 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. In how many rows are the 200 logs placed, and how many logs are there in the top row? Means we can say in the figure that how the logs are arranged. There are 20 logs in the first row, means the row which is at the bottom. Then in the next row 19, then again in the next row 18. So like this they are going to arrange 200 logs. So in how many rows we can arrange these 200 logs, and how many logs are there in the topmost row? This we have to find here. Here total means sum we know, that is 200. So let's find how many rows are there. So here Sn, sum, is 200. Number of logs in first row is 20. Then in the next row it is 19. In the third row it is 18, and so on. So here what does this mean? Here this 20, 19, 18, this forms our AP, where as we have written here, first term is 20, common difference 19 minus 20 is minus 1. Here D is minus 1. Now we have to find number of terms. We have to find the number of rows. So we have to find number of terms. Let's use our formula of Sn. Sn is equal to n upon 2 into the bracket 2a plus n minus 1 into D. Here Sn is 200. 200 is equal to n upon 2 into the bracket 2 into 20. A is 20. N minus 1. N we have to find. Common difference is minus 1. So here we substituted whatever terms we know. Let us cross multiply here. 200 into 2 is equal to n into the bracket 40 minus 1 into n minus n minus 1 into minus 1 plus 1. 200 into 2, 400 is equal to n. 40 plus 1 is 41 minus n. Now we have to multiply this. 400 is equal to 41n minus n square. Now here we have to form one equation, quadratic equation. So here this n square, whenever we solve the quadratic equation, the square term, it should not have negative sign. Always we prefer it to make it positive. So here we will shift this minus n square on LHS. N square minus 41n plus 400 is equal to 0. Now this is our equation where product is 400 and sum is 41. So what are going to be our numbers? Here the numbers are 25 and 16. 25 into 16 we get 400 and 25 plus 16 is 41. So let us split this 41 as 25n and 16n. Minus 25 minus 16 makes 41 plus 400 is equal to 0. N minus 25 minus 16, even here n minus 25 is equal to 0. N minus 25, n minus 16 is equal to 0. Now here either n minus 25 is 0 or n minus 16 is 0. If n minus 25 is 0, n is equal to 25. And if n minus 16 is 0, n is equal to 16. Now here we get two positive values of n. That is 25 and 16. Now which is the correct value? Because n is number of terms, it's always a natural number, and here our both the values, that is 25 and 16, are natural number. So which is the possible value? Let's check this. Here, if our n is 25, okay, if n is 25, then what is going to be the nth term? Means number of logs in the last row, that is 25th row. A plus n minus 1 into d. Here 20 plus 25 minus 1 into minus 1, because our d is minus 1. 25 minus 1 is 24. 24 into minus 1 is minus 24. 20 minus 24, we get minus 4. And this is not possible because this nth term is going to give us the number of logs in the topmost row. And here the value comes minus 4, which is not possible. So number of rows cannot be 25. So now let's consider n as 16. So let's find what is an in this case. A plus n minus 1 into d. 20 plus 16 minus 1 into minus 1. 20. 16 minus 1 is 15. 15 into minus 1 is minus 15. So 20 minus 15 is plus 5. Yes, this is possible. Number of logs can be 5 in the topmost row. So here, what is our question? How many rows are there and how many logs are there in the topmost row? So here number of rows is 16 and number of logs in topmost row is 5. So here we complete our problem number 19. Let's move to problem number 20. These three problems, that is 18, 19 and 20, they are quite different, quite interesting and bit lengthy. So let's start our problem number 20, the last problem of this exercise. Problem number 20. In a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato, and the other potatoes are placed 3 meters apart in a straight line. There are 10 potatoes in a line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drops it in the bucket, runs back to pick up the next potato, runs to the bucket to drop it in, and she continues in the same way until all the potatoes are in the bucket. What is the total distance the competitor has to run. So we all know how is the potato race. We have to stand at the starting point, pick up the first potato, put it in the bucket, run to the next potato, come back, put it in the bucket. Like this we have to collect all the potatoes. So here the total distance, okay. So to find the total distance is, now to pick up the first potato, we go up to the first potato and again come back. So this is the total distance what we cover in collecting first potato. Similarly, go to the next potato, again come back. This is the total distance covered to collect the next potato. So like this we have to find how much the competitor runs to collect 10 potatoes. Let's see how much this competitor runs. This is our problem number 20. Now here the distance covered, okay, now the distance covered to pick up the first potato. For first potato, the distance covered is 2 into 5, that is 10 meters, because it is placed at 5 meters. And next potatoes are placed at the distance of 3 meters. Means here the distance covered for second potato is 2 into 5 plus 3. 5 plus 3 is 8. 8 2s are 16. 16 meters. Similarly, now the distance covered to collect third potato is 2 into, now here 8 plus 3. 8 plus 3 is 11. 11 2s are 22 meters, and so on. And so on. Like this we have to find. So here this forms our AP. 10, 16, 22 and so on. So like this we have to find sum up to 10 terms. Here our A is 10, D is 16 minus 10, that is 6, and number of terms is 10. Let's find what is S10. Our simple formula of Sn, that is n upon 2 into the bracket 2a plus n minus 1 into d. Here n is 10. 10 upon 2 into the bracket 2 into 10 plus 10 minus 1 into d is 6. 2 1s are 2 5s are 5 into 2 10s are 20 plus 10 minus 1 9, 9 6 are 54. So this is 5 into 20 plus 54 is 74. 5 into 74, 5 4s are 20, 5 7s are 35 plus 2, 37, 370. So here total distance the competitor has to run. Total distance the competitor has to run is 370 meters. So here we complete our exercise 1.3 of arithmetic progression of standard 10. So as I requested, please do subscribe our channel so that you will get the regular updates of such useful videos, and do share these videos among your friends. So my dear students, thank you so much for watching this video.